Hello everyone and be welcome to the channel Cubex3. And in today's video we're gonna talk about a single entry point. That's basically a programming architecture pattern. The single entry point is one of the most interesting and extremely useful patterns that exist. Basically, instead of you starting all the process that you have at once, you make step by step, make one process starting, executing, and finishing, and after all that, you start another and repeats all the process step by step. Basically, you make a chain of reaction. Imagine it, instead of all the process that you have, instead of out of them being a mountain that you have to climb to reach the top, imagine them being a staircase that you have to go step by step to reach the top. So instead of you climb a mountain that is more difficult because you have to climb an enormous height to reach the top, you just need to walk in the staircase. So you basically walk using this architecture. And to that you can use it for anything in your life. Your own life, your games, your musics, your arts, in anything that you want to make. All the things that you have to make are all process. Slice the process that you have, the projects that you have, the games that you have, in small steps. That's basically the principle of this architecture. Could you already imagine what this architecture can do? Not only in programming or games, but in anything that you want. Apply this to your life and you see a extremely difference in it. Do it, my friend. Go further and further with this. We'll go. The two projects that I have, both of them are implementing this single entry point, and in this video I'm gonna show the implementation that I put in the BankQuest project, that the implementation of this is more simple, and because the game is more simple and don't have so much things to do and load and create and so on, all the things I created in the runtime, so there's no so much thing to create in the loading or both scenes or levels or so on, and they are more simple to explain and to show to you how this works. And the next video of this video here, I'm gonna show you the the project, the Guamba Prime Adventure project, the implementation that I put in that game. And with this, right away, I'm gonna show to you how this works in the BankQuest project. So, as you can see here, I'm in the enemy spawner script. This script is responsible for spawning the enemy in the level. I'm not responsible for anything else. And this script has two implementations of singularity point. The first one is in the spawn of the enemy, properly said, and the second one is the next spawner. So the first thing to explain is here is the list of enemy handles that the enemy spawner has in the next spawner that the enemy has. I'm gonna explain the enemy handle first. The enemy handle is basically the how the enemy gonna spawn in where it's gonna spawn, has a statistics to spawn one specific enemy, has the points where this enemy gonna spawn, and the delay to enemy to be spawned. And in the enemy points has a spawn point, a point where the enemy is gonna be, and a rotation angle. This rotation angle says how the enemy gonna spawn in how rotation it gonna be. And the statistic enemy that it has, the enemy handle has, is this statistic here. As I already showed this in in a previous video, but I didn't explain so much, and I don't explain so much in this video either. But this is basically the statistics of the enemy. How the enemy gonna behave in this scene. So here in the spawn method, we cast across all the points that the specific enemy gonna spawn, and we spawn each enemy for each point. We spawn one enemy for each point in that case. Here, as you can see here, we go to each point we have. And after that, we increase the index of the enemy, the index of the enemy handle that we have. We increase to the next enemy handle in the list. See here we increase and we get the next delay to the next enemy in spawn to the current handle. So increase the index here and to the enemy handle here to do with the index increased, we get the delay to the to the specific enemy in the enemy handle. And here it is here in the start is basically some st- starts for the enemy spawn to start. And the update method is here where we update the we is here is where we get the loop to the spawn occur. And this is the first security point. It's very simple. Basically, you even can call this security point because these are basically one process and don't are a bunch of so successful. Don't are a bunch or sequential process at one after another, but because there a bunch of enemies sequentially getting one after another, I call it a secret implementation of a security point. And the second implementation is with the next spawner. Every spawner has a reference to other spawner because the next spawner gonna, as you can imagine, spawn next after this spawner here finish its job. So after if the index is bigger or equal with the enemy handles that this spawner has, it gonna verifies it if it has an enemy spawner and spawn the next enemy. Or of course, if the next spawner is in this scene is inactive, it's gonna spawn the enemy. And if it's not in this scene, it's gonna instantiate the spawn in this scene. And that's basically it. And also, we destroy this enemy spawner to don't have a object in this scene. That's basically it. It's very simple. Of course, I'm gonna go to the Unity editor to show more of this in the practice, of course. And with this, you're gonna see how this works, how this do. Of course, all of this that I showed, all of this is just to you understand the principle of the singularity point. But in the next video, in the second part of this video, I gonna show a more complicated way, a more complex way to how the singularity point works in a loading. How did gonna how it's gonna works in a loading properly. That the load is the main way that the singularity point is used. So finishing this, I gonna go to Unity Editor to show this in work. As you can see here, I'm already with the Unity plane, and you can see here I have two enemy spawners here, and the second enemy spawner is attached to the first enemy spawner. I'm gonna see the enemy spawner here. As you can see, I have this enemy spawner here, and I'm gonna click in this. You're gonna see it's the second enemy spawner here, and the second enemy spawner has none on it, so it's gonna instantiate nothing. So I can see here, I'm gonna enable this enemy spawner here to see it working. I put a delay in the first enemy. As you can see, it spawned three enemies. And as you can see, the second spawner already has spawned, and the three enemies have has spawned also. As you can see, the first I already gonna pause this. Do you see all the enemy spawners have been used? There's nothing in it, as you can see. The first and the second spawner are not here. They all of them have been destroyed, and all of them have been has spawned three enemies. I'm gonna also enter this scene here. In this scene has both of the enemies, and as you can see here, the first enemy has two of three enemies of three enemy handles here. The first enemy are just one enemy, but they all spawn in one specific spawn, and both of them have a delay to spawn. And as you can see, the enemy spawner 2 have here, and the second spawner has the same thing, all the same thing. And that's basically it. That's all that I have to show to you in this video. There's a lot of things that I didn't explain in this video, like the insane builder and the insane batches. Why I didn't explain this? I didn't explain this because they are way more complex to explain. Of course, they are meant to use the singularity point more in a more proper way than these two implementations that I showed in this video, but they are way more complex to show, and because they are used in the second project that I have, the Wamba Prime Adventure project. This game project that I have has a way more complex and structured load system, because the scene builder in the scene batch that I made are meant to be used in the load system. So they are gonna explain in the second part of this video because of this. And in this video, you gonna see how the single entry point is used properly, because these two implementations that I show in this video are not two proper implementations of the single entry point. I call that because they follow the principle of the single entry point, but you can call it a single entry point properly in that true way. And this was all the video that I have. Please, if you like the video, comment the video, subscribe, and share with your friends. If you have a friend to show to share, if that you like, or if you like the video, share the video, please. Comment anything that you want for the future. And that's basically it. That's all the video, and goodbye.